So transformation examples in 3.4 for trig is what we're looking at right now. So let's take a little gander here at some examples. So this one and this one and this one here, find out whether even or odd or neither. So plug in a negative x. An even number of negatives makes it a positive. An even number of negatives makes it a positive. So look at the exponents. Here's another easy way to tell if all the exponents are even. All the exponents are even. There you go. It's going to be even. If all the exponents are odd, it's going to be odd. So without you even plugging in negatives, you can figure that out. And if they're different, right, all the exponents are not even and all the exponents are not odd, meaning that's going to be neither. Just tell me how it moves. Don't need to graph it. So when you tell me where it shifts, you can tell me that it moves up 7, okay, on the y. You can tell me it moves right 3 on the x, right? And you can tell me that you would multiply the y's by negative 1/2, which means it flips over the negative, right? That negative means it flips over the x-axis, and that half means that it gets wider vertically. Alright, this one here, that means it goes down 4 on the y. That means I divide by negative 2 on my x's, and it means that it's compressing, and in the middle, I know that I don't shift it to the left or to the right at all, and that 4 means it's getting thinner because it's greater than 1, so it's getting skinnier. And yep, that compresses horizontally because it's greater than 1. This right here, this one, I'm moving up 7 on the y. I'm moving left 6 on the x. And that 4 means it gets skinnier vertically. It means it's getting skinnier. This one right here, I'm moving it up 2, right? So up 2 on the y. That, to see if it's moving left or right, I need to solve it. So I add 5 to both sides, divide by 3, so I'm actually moving it to the right 5/3 on the x. That negative means I flip it over the x-axis. That 2 means it's getting thinner, it's getting skinnier. So just some things to keep in mind. And that 3 there, I would divide the x's by 3. Which also means that it's compressing as well. So those are just some descriptions of how the transformations work. I know that they went fast through them, but you can slow it down to see how you move through them. Realistically speaking, the only purpose behind this is to see how to shift things. Graphing wise, you can just graph whatever we give you. Okay, really, you just can on a graphing calculator. It's that simple. Just graph what you can on a graphing calculator. But the point I'm getting at here is not that. The point I'm getting at is for you to take a look and just realize how they are supposed to move. Okay,